difficult to find what?
Combine something.
Combined.
Yeah.
Which means I have the account over here also. I move to another state, I have account here. So I'd like to sum up my balance. How can you sum up the balance? Access this one, go back, access this one, and you need to check all of this.
Yeah.
Very hard. The sum of the balance of my account throughout the bank, even though I'm using only one bank.
Yeah.
So this is the drawback of the hierarchical database. So Dr. E.F. Code in 1969. So 1969 is what? Yes. So I will give the bonus point. So Dr. E.F. Code in the IBM T.J. Watson Center nearby. So he proposed the new idea of the management very large data. It works for the certain amount of the data, but when we have the very large data, 1 million of the customer, each customer has the different account in the different branch, it doesn't work. So Dr. E.F. Could think about how to manage the data efficiently. At that time, he adopted the idea of set theory. So why don't we consider the data as a set? What is a set? Set is a set of group of element. Okay? So why don't we consider each data, each entity in ER model, each entity as the element as a set. This is entity type. In other words, this is relation. Actually, relation is a set, not the relationship between you and me. So when we are saying the relational database, relation means a set. So this is a one relation, one set, one unit to manage the data. So for example, student set. Student relation is a set of student element. In other words, student is called tuple because Dr. E.F. Code, he probably needed to differentiate his idea from set theory. Even though he adapted the set theory idea, when he proposed, he makes his idea brand new. So he used a different notation. Instead of element, he said it's a tuple. This tuple, each tuple consists of what? Certain attribute. Okay? So for example, we can make the set like this way. Element doesn't have to be just one value, it's a group of values. What? Think about, why don't we replace Lee, 1, James, CS, it's a CS, and Paul, electrical engineering, something like that. It looks like the entity, right? So by grouping, this is the student set, student relation. That is the idea of relational database model. So why don't we consider a group of data as a set, which is called relation. That is relational database model. What's the benefit of using such a set? Where is that? It's a formal, very strong fundamental to design the new model because it's based on the set, mathematical model. Also, we can use a lot of bunch of mathematical operations, set operations, which are already proved. You don't have to worry about the intersection. What is the intersection? What is the minus? What is the plus? What is the union? It's already proved in the set theory. We can just adapt. We can just improve. So that is the benefit of using a set model, that is the relational model. So, by the way, after Dr. E.F. Code, Dr. E.F. Code was in the IBM Research Center, in T.J. Watson Center, still existing, very popular research center. But unfortunately, IBM didn't support the Dr. EF code to make it commercialization. Because at the time, IBM used hierarchical database a lot. So IMDB, IMSDB sometimes. So they actually gave up to fund the relational model, new idea. So Dr. EF Code and his colleagues and quit the job from the IBM, then make the new company. Then the test, and several, probably more than 10 years later, and sometimes 80, he announced and his group announced the new relational database management system, which is actually Oracle. So Oracle is from version 9 at the 5 or 6, it was commercialized the first time. Then eventually, which is the most popular DBMS system, later IBM realized the relational model replaced most of the database management system. So IBM resumed the research and the new product for the relational model, that is DB2. Then DB2 was not enough to compete with the Oracle. They purchased even the Informix, the relational database model, database management system, but still the first market share product in database management system is more, I think the more than half is Oracle. And the other, the half will be shared by the Microsoft SQL Server and the IBM DB2. Some of them are Informix. Sybase is one of them. Actually, the Microsoft SQL Server is only for single user, which means it doesn't support the multi-transaction, because think about the Microsoft operating system. It was only for single user. Now still many of the personal users use the Microsoft, the operating system, as a single user operating system, even though it supports multiple transaction, multiple user. Okay? So Microsoft also realized such a supporting multiple transaction is important, so they purchased the transaction model from Sybase. So actually the core part of the SQL Server is actually from the Sybase DBMS system. Okay, so let's define the definition of the relation and relational model. But we are going to use such an informal way. Informal way means it's not standard, it's not inefficient, it's the descriptive language. Using the descriptive language, I'm going to explain what is the relation. So relation is a group of data. Group of data. It's a relation. Student set. See, eventually it will be, do you know what is a table in the DBMS? I think many of the students heard about the table. Eventually you are going to create the table using the DBMS. So this relation, student relation, is the entity actually. From entity is a group of the student, group of the data. So that is a relation. So it's a set of rows, set of the tuples, set of the data, set of entities. That is anyway, set of whatever. That is the relation. One more thing. For example, I have the data for student. One student is a Lee, who is 30 years old. Am I 30 years old? So major is computer science. So this is one data, one entity, one element, right? We have another James, 20 years old, electrical engineering. We have a Paul, and 25 years old, mechanical engineering. Yes, we have three elements. Group of element is a set or relation for what? Student. This is a student relation. Student set. Student. So according to the definition of the relation, this is a relation. This is a group of the data that we are going to manage. However, why don't you consider the attribute by attribute? Each element has the same attribute, like the name, age, and major. Just like the entity and entity type. Type can be described by group of attributes in ER modeling. We are discussing about the relational model, not ER model. It's a different, quite similar but different. So this is the attribute, attribute, attribute. Can I say student consists of name, age, and major attribute? Yes, we can describe student as this way. So this is another definition. Relation is a set of attributes. What column? Why don't you think about the table style, like the Excel, Microsoft Excel. It has a bunch of grid. This one is row, this one is column. Okay? So a set of column, a set of attribute, also relation. That's the definition. Okay? By the way, most of the DBMS, right now, the current DBMS system support row by row, what data by data online. So you can access the data by row, but not much this one. This is called row-based database. This one is called column-based database. The reason is that most of the designed database has small number of column but huge number of data, like 1 million of data. Why? 10 column or 20 column or sometimes 100 column. The number of column is relatively small than the number of data. But now that's the reason row-based access is very important, critical. However, nowadays number of column is increased a lot. Sometimes you have 1 million of the column attribute. What can be the example? DNA? DNA? For example, sensor. So why don't you distribute the temperature? Sensor to check the temperature. And worldwide. So each sensor will be one column. Sensor 1, sensor 2, sensor 3. So 1 million of sensor. 1 million of the column. So column-based approach is, even the DNA sequence, this also can be one example. Types of DNA, and whatever. So column-based database is nowadays very, very important and critical. Also data warehousing. I don't know whether you guys know about the data warehousing. This also has a lot of, sometimes 1,000 attributes. Okay, so column-based approach is getting important. It's another hot issue in database research. Anyway, we are going to deal with such a data row by row, but it can be defined. Relation can be defined as a set of columns. So this can be the formal definition. So instead of a set of data, a set of the tuple set of attribute, what are these? Relation R has A1, A2, AN. That means attribute, each A indicate the attribute, a set of attributes. Okay, this is the formal definition. Okay, so for example, the customer has customer ID, customer name, address, and phone number. Each attribute has the domain. What's the domain here? Size? Type. Closer, 90%. Do you know the data type in the programming? What is the data type? For example, integer, float, character, or object. It's a data type that limit the organization. In other words, data structure of the data, right? So for integer data, you cannot insert the real data or other types of the data. For character, you cannot use the different types of the data. So it limits the structure of the data. It's also data structure. That is a data type. Domain is not, it's similar as a data type, but it's a kind of job that includes all the possible data. For example, what can be the example? Phone number. What is the data type of the phone number? Numbers, character, not clear. But you know what is the organization of the phone number, right? 3 area code, then followed by 3 number, and followed by 4-digit number. So if you put all possible numbers here, 111-111-1234, and 111-121, all the 3 number by 3 number by 4 number, this is called data domain. Okay? So domain is the possible data that satisfies with the requirement of each attribute. Actually, when Dr. E.F. Code proposed the relational database model, he never used the data type. Instead, he used the data domain. So we will, actually data domain is much more accurate than the data type. Like the phone number. Is there any data type for the phone number? No. Instead, you need to define as an object, something like that. But phone number is more accurate. We don't need 11-digit number. We don't need any other. We need a 3 number followed by 3 number followed by 4-digit number. That is data domain. Not many DBMS systems support the domain, but there are DBMS that support the domain. Okay? So, example of the data for customer is like this one. We can get the customer ID. From where? Customer ID domain. We pick up that, one of them. John Smith, it's the same thing. Name, not character, whatever. So from the domain, we pick up one of the examples of the data. Then address is the same and phone number is the same. This is the called tuple. One tuple, one data, one row. Okay? By collecting all possible tuples, it will be customer relation. Eventually, that relation will be a table that we are going to manage. And also, first we need to create. So relation can be the set of tuples. Okay? So domain, I already explained about it. So this is the formal definition of the relation. Usually first, we use operator for, it's not the good, but usually we use operator for to denote, indicate the relation name, eventually table name, and attribute. It's A1, A2, whatever. Also, each relation, each data is the small letter, lower letter, okay? And some tuple, something like that. So using that notation, so this is the, so given relation A1 through AN, what is the tuple? Tuple is from, we pick up the one data from A1 domain and A2 domain, AN domain, and what is this? Multiplication? What does that mean, multiplication in set theory? Can you multiply element by element? It's a Cartesian product. So you learned about the Cartesian product actually in your, I think, the middle school math or the high school math. Cartesian product is all the combination of your element. We will see such an example next slide. So it's a combination of the all sample data is the tuple of R. tuple of the relation. Okay? For example, we have S1. What is the S1? What is the S2? Yeah. It's the attribute domain. S1 attribute. Let's say S1 is the name. S2 is the name. S1 is the ID. How many different IDs? Only 2 IDs. How many different names? 3 names. A, B, C. Can we make the relation using these 2 domains? Yes. How can we do that? It's the S1 Cartesian product of S2 combination. So like this one, 0A, all possible. 0A, 0B, 0C, 1A, 1B, 1C. 6 of them are possible for the sample data, but not all of them is a subset of Cartesian product. Okay, that is the relation. That is a table. Some of them already know about the table, and the others are not. This is the origin or fundamental of the table that you know. Actually, from relation, we define the relation, then eventually it will be table. In this case, R is the table, R is the relation. How many tuples? How many data? It has only 3 data. Okay, 3 rows. So some of them are already confused because I'm using different notation. So from now on, I'd like to clarify the terminology that we are going to use in this class. This is an informal term. Informal term means it's not mathematical. It's just for your understanding. But what formal term is, it's used for mathematics. In other words, if you propose new idea, I have a new idea in the relational model, so I'd like to show my idea to the conference or society, to the journal article. At that time, you should use this formal term. Okay? But in real life system or the real life project, informal terms are used frequently. So let's see. Like the table. You know the table, and I explained the several times, mentioned several. Table is the informal term. It's the same meaning in the relational model. Formal term, that is a relation. Okay? Column is the attribute, row is the tuple, value in the column is the domain in the formal relational model. And table definition is the schema of the relation, populate the data is the extension, and so on. So from now on, I'm going to use both of them interchangeably. Sometimes I use the informal term, sometimes the formal term. This is the example of the relation of the student. This is a relation. What is the definition of the relation? Group of the tuple, group of the data. Each row indicates one element in set. So it's a group of the element, group of the data. One group of attribute, also a student relation, student table. Okay, that consists of name, SSN, home phone, address, phone number, age, and GPA, and so on. However, each of the tuple, each of the data should have the exactly same organization, same attribute. But sometimes we do not have the data over here, like for example, Benjamin Baylor does not have the office phone number. So it cannot be common. That's the problem. So we will see how to address such a thing. There are 3 important characteristics in the relation. So we will see such a characteristic of the relation in the next class, not the Thursday. Thursday we will have the first exercise lab regarding to your connecting Oracle database, as well as the ER modeling and ER modeling using the Irwin software. So please come to the lab. It's 164. First section is from the 1:30 to 2:45. I'm going to call your name. The section 1 first. Abdullah and Sarath, Chandra, Diaz, Bender, Demar, Ariz, Manor, Faisal, Russell, Faisal, Fang Ying, Siyun, Mohammed, Mahdi, and Nurti, Hui, Yahweh, Chao, Junzi, and the undergraduate student will attend the first section from the 1:30 to 2:45, and the other student, Bharat Kumar, Saad Sultan, Ibrahim, Wafa, Hatem, Faisal, Abdul Rahman, Hao Yufeng Yan, Abu Bakr, Tian Shu Gao, Su Li, Han Yuan, Didier, Lei, Zibo, Bei Xiang will attend the second section. Okay? So thank you so much. We will see you on Thursday, and we will continue the lecture next week. Why don't you submit your homework?